Finding vertical asymptotes is a pretty straightforward process, and it's something that you've already done. The trick here in our work on limits and various ideas is that we've seen a variety of functions that result in the 0 over 0 or indeterminate form. And it turns out that that has powerful implications for how we go about finding asymptotes. Generally, the way you've been taught to find a vertical asymptote in the past is find places where the denominator is 0. Anytime the denominator is 0, that leads to a vertical asymptote. Well, it turns out that's true as long as the numerator is not 0. 0 over 0s, as we've been seeing, often can be turned into limiting values that have specific numbers associated with them. And that means that the graph approaches that number on each side. It doesn't approach infinities. It doesn't look like an asymptote. It actually looks like it approaches something. So in the picture that I've shown you here on our calculator, you can see at the top that I've graphed the function x squared minus 4 divided by x minus 2. Surprisingly, this looks like a straight line. I used the trace function and entered in x value of 2 to show you that when x is 2, we don't get any kind of value for y. But we don't get an asymptote when x is 2 either. And that's because if we look at the top and factor it, we'll get x plus 2 times x minus 2. So we get a 0 over 0 form. That is, we get an indeterminate form. That if we cancel the x minus 2's, we end up with the graph of just x plus 2, and that's the graph that you're looking at here, essentially. The difference between the graph of x plus 2 and this graph is that x plus 2 actually has a value when x is 2. The graph of x squared minus 4 divided by x minus 2 doesn't. It has a hole in its graph, but it doesn't have an asymptote. So what you need to make sure that you're doing when you're looking for vertical asymptotes is making sure that when you find a 0 in the denominator, that the numerator isn't also 0 at the same time. Two ways to get around this: use the dividing out technique as you've seen, or use the rationalizing the numerator technique as you've seen. Both of those can help by simplifying the function, and once the function's in simplest form, then finding asymptotes, and more specifically vertical asymptotes, is much more straightforward.